That doesn't seem like it's in the right spot. All right. So today we're going to talk about parabolas, and we're not going to talk about the form y equals ax squared plus bx plus c. And we're not going to talk about the form y equals a x minus h squared plus k. This was called standard form, and this one was called vertex form. Does that look familiar? Okay. We're going to talk about parabolas as a conic. There's a tiny little picture here. Remember we talked yesterday about how if you sliced that cone a certain way, you'd get a parabola. All right. There's a fancy definition for parabolas we're going to address here in a second. But first, this is on worksheet 1B. If you want to go back and write it down, great. Otherwise, I think we skipped it yesterday. If it's blank on your notes, I won't yell at you when you turn your notes in. But do you remember how we completed the square? Because we're going to have to do completing the square today. So I wanted to revisit this because we all were feeling pretty confident about it yesterday. Remember what we did first? We put the x's together, and over here we put the y's together. And someone help me with the x's. What do we get in this parenthesis? Yep, we took half of this, making careful to watch the sign. And if we multiplied x minus 6 times x minus 6, we'd get x squared minus 12x plus 36. Okay. And then we went over here. Good job. Took half of this. So we ended up with a y minus 14 squared. 14 times 14, 196 maybe, guys? And 196 and 36 were supposed to be added over to this side. I forgot my blanks. I'm already having a good morning, huh? 9? So the center would have been at, anybody? 614 with a radius. This is r squared, remember, so the radius is 3. Okay, feeling okay to remember completing the square? Because we're going to have to build on that today. Okay, that was my warm-up. This is where parabolas are used in the real world. How many of you have been to St. Louis and seen the arch or been up in the arch? Some of you? Very claustrophobic. Very not fun if you're claustrophobic going up in that thing. Satellite, super useful. Some are hyperbolic, some are parabolic, but we're going to talk about a point in the middle here today called the focus. And the focus is where like a satellite receiver would be if it was a parabolic satellite dish. Okay? So just a few places in the real world where there's parabolas. Eventually, you're going to have to be able to graph, finding the points that are called the focus and vertex. You already know what a vertex is. And a new line called the directrix. Okay? The axis of symmetry and the vertex we've done before. And you're going to have to complete the square, and then you're going to be able to write an equation given some of those things. All right. You will get a reference sheet on this unit. Looks like this. Everybody find it on the blue sheet where the parabolas are? Okay. So the fancy definition of parabola, and I can quickly talk about this as a useful application. If there was a highway here, and we'll say your house was here, and you and your spouse or significant other wanted, or you wanted to work in a place that was equidistant from this house and this highway. I don't know why you'd need to do that, but anyway. If I put a point over here, does everybody see that that distance is the same as this distance? If I put a point right here, that's pretty clear that that and that are the same, okay? But I could also put a point up here somewhere. No, that's not looking good at all, Hochbauer. Let's try again. Oh, let's get rid of those. Let's go over here somewhere. Whoops, I lost my pen. Does that look like it might be the same distance from here as it is from here? Okay. What's happening is all of those points will eventually form a parabola. So the definition of a parabola is that all of the points that fulfill the parabola are the same distance away from this one point called a focus as they are away from this line called the directrix. So in this picture, D1 would always equal D2. Now, I'm not going to ask you that on a quiz, but that's the fancy definition that we're working with, okay? I'm going to go here. So again, the point in the inside is called the focus. The line that it bends away from is called the directrix. Now, for the first time, we are going to have parabolas that open sideways. Okay, we've not had that before. So we are going to do focus and directrix here. I'm just going to write D. The vertex we're used to, that's where it changes the bend right here, right? I'm going to write next to this that this would be a y equals equation, and this directrix would be a vertical line, so it would be an x equals equation, okay? That might help some of you later. All right. So what is always inside of the bend of the parabola? What point are we going to put here? Yep, that was called the focus. And the directrix is the line that always lies outside the parabola. That directrix is perpendicular to, does anybody remember what this was called? Right down the middle? Yeah, axis of symmetry, perfect. So the directrix and the line of symmetry or axis of symmetry are perpendicular. That seems clear. It's not something we are going to spend a lot of time with. All right, this is the biggie. There is a special number you are going to have to know and use. Did anybody look at the reference sheet? Was there a number on there or a letter that you don't recognize? P, this crazy P value, okay? The definition of P is that the vertex is P units away from the focus and from the directrix. So on your picture here, this distance is P, and this distance down to here is P. Same thing here. Now, when P is an integer value, a nice whole number value, that's great. Unfortunately, P is often a decimal or fraction, okay, a small fraction. Let's see, is a segment, oh, this is an interesting one. This is called the latus rectum. I have no idea who came up with this word. It sounds like something from Fairly Odd Parents. Did anybody remember that show? They always talked about Uranus. Made jokes. This is the latus rectum. Okay. What it is a point that passes through the focus with the endpoints on the parabola, and it has a total length of 4p. Now, if p is a nice integer value, the latus rectum is helpful. If it's a fraction, it's not. So I am not going to spend a lot of time on that concept, and I do not require that you do it in your notes, okay? It was just helpful in graphing. All right, can you copy these in there, guys? Standard form. This is on your reference sheet as well. When the x is squared, okay, this is how I remember this. We've always done parabolas with x squared, right? And they opened either up or down. So now when we all of a sudden have ones with a y squared, they're going to open left or right. Now, if you think about this, it kind of makes sense. When this p is positive, it's going to open up or to the right. When the p is negative, it's going to open down or to the left. And I don't care if you put these greater than 0 or less than zeros, if you just write positive and negative on those blanks, whatever makes most sense to you, it's your notes. If you're one of those people who those little less than's always confused, maybe just write positive, okay? Less than's, greater than's. Any questions? All right. On the back now, we are actually going to start with number 2. So can you make sure that you're graphing with me with number 2? Start with number 2. Don't do number 1. Don't put it on number 1. You'll be upset with yourself. Okay. If I go to the reference sheet, there's one that starts with a y minus k squared. Looks like this, right? Y minus k squared equals 4p x minus h equals 4p x minus h. I'm going to write that underneath here because I want you to pick out some things. What do you know right now? It's k. Yeah, because it's y minus k. So k is negative 2. Good job. What is h? A little confusing, but is there anything over here? So h is going to be 0. What's multiplied by the x is 4p. So we have an 8 in the spot that's supposed to be a 4p. So we can say 4p equals 8, which makes p a nice integer value of 2. All right, is this one going to open up or down, left or right? Look on your notes. It's going to open either left or right because the y is squared, and it's got a positive p-value, so it's going to open to the right. That's a biggie before you get started because I always do them wrong if I'm not super careful. All right, the vertex, according to the reference sheet, is hk. It says it right up here as well. So our hk would be 0, negative 2. I'm going to go over here across 0 and down 2. That's going to be my vertex. Okay, if this, I don't think I want to put that v there. If this is opening to the right, where's the focus going to be? P is 2. Yep, perfect. It's going to be 2 units to the right. What does it actually say on your formula sheet, guys? Can you look? Here, if it opens to the right, it says the focus is at h plus p comma k. So over here we had h is 0 and p is 2. So that gives us 2, and k was negative 2. Did that make sense for what we drew? 2 units to the right? It's at 2, negative 2. There's 2 ways. Either students are very comfortable with the concepts, or they're very dependent on the reference sheet and the formulas, or what I like to call the recipes for finding these things. And I'm okay. I'm not going to take that reference sheet away from you. So if you want to just use the reference sheet, it's all good. Let's do the axis of symmetry next. The axis of symmetry goes right through both of those points. Can anybody tell me the equation of that? What does it say on your sheet? Axis of symmetry. Y equals K. So it would be y equals -2, horizontal line where all the y values are -2. Okay, directrix is 2 units the other direction from the focus. If this is the focus, we're going to go p units back this way. And that's the directrix. Okay, it was 2 units back that way. So it has an equation of x equals h minus p. Is that what it says? Okay. So h was 0, p was 2, so 0 minus 2 is -2. Is that making sense for where we drew it? Okay. Now, because our p-value is a nice 2, we can use it to, and this idea of the lattice rectum, because 4p was a distance of 8. Remember it says up here, use 4p to find the endpoints of the lattice rectum. 4p was 8. It means a total of 8 units from the focus. So that would be 4 units above and 4 units below. If we wanted 2 nice ordered pairs to draw this through. Oh my gosh, that is so sketchy. It's supposed to be a smooth curve. Mine is a hot mess. I'm not gonna ask you about the endpoints of the lattice rectum. It's the total distance or length is 4p, which was 8, so it was 4 either way, and it's in line with the focus. I will never ask you where the endpoints were. And sometimes it's just not even very helpful. All right, how we doing? All right, we're going to go back and try number 1. Go back and try number 1. Underneath this, I'm going to write the generic form, which is x minus what? Because this one starts with an x, it's x minus h squared equals 4p y minus k. All right, someone tell me something. Maddie, can you tell me 1 h, p, or k? H equals 4. Riley, can you tell me something? Anybody help him? Phone a friend? What's K, guys? -3. And 4p equals 2, which unfortunately, when we divide by 4, gives us p equals 1/2. Okay, anytime the p-value is less than 1, you're going to get a scrawny little parabola. I'm telling you now, okay? All right, vertex. The vertex is always hk, no matter which way it's opening. So this one is at 4, -3. Which way is this one opening, by the way? The x was squared, so it's opening either up or down, and the p was a positive, so it's going to open up. All right, so let me plot that point. 4, 1, 2, 3, 4, -3. All right. The focus is, by definition, do you remember what the concept is? That the p-value tells us how far away to the focus? So it's half a unit up this way. And the directrix is going to be half a unit back down this way. So what is the actual formula off the sheet? Somebody have it for the focus? H plus P comma K. Okay. Yes? When it's opening up and down or not? Yeah, that's what I thought. This would be moving it left or right. It's got to be the one that's opening up and down. It's a different formula when it opens up and down. That's why you got to be super careful here. It's this one. Everybody got it? Whoops, can't write with an eraser. So it's going to be 4 comma, but then we need to do -3 plus 1/2. Can you do that on your calculator if you need to? -2.5, okay? And I would take that. The answer key probably has -5/2. Let me rewrite this, it looks really messy. To find that, we did -3 plus 1/2, which is -2.5, or 4 comma -5/2, which is equivalent to -2.5. Okay. The axis of symmetry goes this way. So what is that equation? Anybody, quick? X equals 4. The directrix equation, y equals k minus p, so it would be y equals -3 minus 1/2, or -3.5, or -7/2. All right. Now, to actually sketch this, the lattice rectum total length is 4p. What was 4p, guys? 2. So the total length is 2 on either side of the focus. So you go 1 unit to the left of the focus, 1 unit to the right of the focus, and that's why I say it's going to be a narrow parabola. I am not going to be super picky about those narrow ones because they're just nasty. I'm just going to write here that it was 2 units long. All right. Rather than do another one of graphing, I want to see if we can write an equation for these. Can anybody tell me what P is on number 1? Yes, it is the distance from the focus to the vertex, right? Or the distance from the vertex to the directrix. So here P is 1. Anybody going to correct us a little bit? Yeah, it's opening to the left, so it's actually going to be a negative, okay? But the distance is 1. What about number 2? P is this distance in between the vertex and the directrix, so P is 2. But this one's opening positive, so it's just positive 2. All right, can anybody tell me the vertex quick? This one had a vertex at 1, 2, 3, 4, 1, 2, 3, 4, 5. Is that 4, -5, guys? So that's H and K. And this one has a vertex at -3, 3, maybe? Anybody? Does that seem okay? All right, so now you just need to go to your sheet. When it opens left or right, the general equation starts with what? Y minus K, which will become plus 5, squared equals 4P. So 4 times -1 is just -4. And then it's X minus H, which would be X minus 4. Can you try number 2 on your own? You awake, Riley? So this one goes X minus H squared equals 4P. Who's got the rest? Anybody have X plus 3 squared so far? How many of you had that one right? Yes? Yay. Just following a recipe, right? As long as I don't take that sheet out of your hand. Okay. We're going to go to the top of, is this worksheet 2A? Thank you. There's a little bit of room up there for notes. I really don't care what you write. I am going to ask you to be able to find the vertex, focus, directrix, axis of symmetry, though I will tell you on the quiz I did not put axis of symmetry. Make sure you think about the direction it's opening. And bottom line, guys, if P is less than 1, just draw a narrow parabola. I am not going to be super picky. Years past, I made students find me at least 2 ordered pairs, even if they were ugly. I'm not going there. We're going to make this painless as we can. I'm really okay if you don't write much here. Anybody? Break out what they want? Ben, you good? Need more time? All right. We are actually going to skip, if you've been working on that one, no problem, but I'm going to skip down to number 3. I just wanted to pick a few. Ew. What is it about this worksheet that's different than what we were just doing? Yes, it's backwards. So if you want to rewrite this as x minus 2 squared equals negative 4y, so that matches up with your reference sheet, x minus h squared equals 4p times y minus k. They just flip-flop the sides. No big deal, right? 2 is equal to 3 would mean 3 is equal to 2. Oh, wait, that doesn't work. Anyway, we can flip-flop the sides. Okay. So tell me something. Where's the vertex? H is 2. And K back here is what? 0. And 4p is equal to negative 4. So p is negative 1. Thank you. Can anybody tell me which way this is going to open? Down. Yep. Do you guys know where she's getting that? Looking at the reference sheet, everybody okay? When it has an x minus h that's squared, it either opens up or down. And this one had a negative p, so it's going to open down. Okay, the vertex is at hk, which is 2, 0. So I have over 2 and up 0. P is negative 1. What does that mean? Where's the focus? You said it's going to open down, so the focus is 1 point down. There's a fancy formula, but if you know the p-value, it's just 1 down that way. And the directrix would be 1 unit up, but it's a line. You can use the fancy formulas off the sheet. So where's the focus? 2, negative 1, does that sound right? And the directrix? Y equals 1. Axis of symmetry, anybody? Would be this line, which is x equals 2. All right. This whole lattice rectum craziness, 4p was negative 4, so it's a total of 4 units across when you go through the focus. Okay, so it's 2 on either side of the focus. All right, I'm gonna skip 4 for right now. Let's do 5. I'm gonna rewrite it so that it's in the order that your reference sheet goes. It has y minus 6 equals 4p. Whoops, I'm doing 2 different things here, sorry. Equals negative 1/2 x minus 2. Then what I was gonna do is put underneath it the form from your sheet, y minus k squared equals 4p x minus h. So Ben, tell me something, anything. K equals, careful, 6. Yep, you're good. And h is 2. There we go. And what is 4p equal to, guys? Negative 1/2. How do we solve that? We have to divide by 4 or take 1/4 of both sides to get rid of the 4, right? So we get p equals what? Negative 1/8. Anybody want to cry right now? Everybody hate fractions? All right, we're going to make this work. Which way does this one open? Left. All right, who can tell me the vertex? The vertex from the reference sheet is h comma k, which would be careful, 2, 6. I have it listed backwards up there. 2, 6 is up here. All right. All right, how about the recipe for the focus and directrix this time? When it's opening this way, I don't have a handy reference sheet here. When it's opening this way, it was a y minus, wasn't it? Is that the right one? So the focus is h plus p comma k, and the directrix is h minus p. Oh, nope, didn't mean to do that. All right, so what did I just say? The focus was h plus p comma k. So can you type 2 plus negative 1/8, guys? I would prefer a fraction, but I will take a decimal, but you shouldn't round it. Be 1 7/8, which is 15/8, anybody? As a fraction, it's 15/8, comma k, which was 6. As a decimal, guys, was it 1.875 or something? So it's just to the left, like you can't even get it close enough on your paper. And the directrix is x equals h minus p. So h was 2 minus, be careful. P is negative 1/8, right? 2 minus negative 1/8 is 2 plus 1/8, or 2.125, I think. Or 2 1/8 would be 17/8. Oops, and it's an equation. I don't know why I started to write ordered pair. All right, so back here, yeah, mine's not even close. I don't know how you draw it close because I can't draw anything 1/8 wide on this graph paper, but it's back here. All right, and remember what I said about parabola with a tiny little p-value? Just make it narrow. Okay, it's narrow. I don't care. Mine's really bad. It should actually be a total of a half a unit. Mine is really too wide. I don't care. All right. I didn't draw the axis of symmetry, and I'm not going to worry about it. It's not on the quiz. It would be right through the middle, right? Let's not spend any more time on that. Oh, no. Guess what we get to do now? How about take a 10-second candy break? Number 6. Everybody find this one? What we want to do is we want the y squared, the squared term, whatever it is, to be positive. So I'm going to move the y's over to the other side. That leaves me an x minus 97 on this side. And what am I going to get if I move the y's over to the other side? Y squared minus 20y. I didn't show my work. Is everybody okay? Adding the y squared and subtracting the y. Okay. Now, if we're going to complete the square, we're going to need to add a blank back here on the squared, which means we have to add a blank on the other side. It's a very random place that I added it, but sorry. All right, and then we need to complete the square. I didn't write this in the order that your worksheet does, or your reference sheet. That wasn't very helpful of me. What's happening over here? We take half of this and get y minus 10, which if you multiplied y minus 10 times y minus 10, you'd get y squared minus 20y plus 10 times 10 is 100. If we add that to that side, we got to add it to the other side. So what do we have over there now? An x plus a 3. Now, I think your sheet, doesn't it start with the squared part? So if we flip-flop the sides of the equal sign, we'd have this. What does that make your 4p out here? Just 1. All right, I'm going to have us practice this one more time. H is what? Be careful. I'm going to write above it because I always get H and K mixed up when it's like this. Yes, H is negative 3. K is positive 10. And 4p is what? 1, so p is 1/4. All right, I promise I won't make, on all the completing squares, we won't have to do all this jazz, but let's practice it one more time. Where's the vertex? H comma K. Negative 3, 10. Okay, which way would this open? If it's got a y squared, it's opening left or right, and the p was positive, so it opens right. Okay. I want to find the focus and the directrix still. I'm going to see if I have a reference sheet handy. Is there one in the slides? Here we go. It says when it opens right, the focus is at H plus P comma K. Do I have the right formula, guys? H plus P comma K. So negative 3 plus 1/4 is actually what? Negative 2 3/4 or negative 2.75. Did anybody get that? Negative 11/4. And you can write negative 2.75. I'm okay with that. And it's comma K. K was 10. And then the directrix. let's see if this is opening left and right. It's an x equals, is that right, guys? Is it x equals h minus k? H minus p? Wow, I think I wrote k there. It's supposed to be p, right? So this would be x equals -3 minus 1/4, which is -3.25, or 13/4, you said? X equals -13/4. Sorry, could I have written that any smaller and scrunched it in there? Are we almost out of time already? All right. We're going to have to do some more parabolas another day. I'm going to go through this number 7 though. Your assignment tonight, guys, is to work on the 6 problems on worksheet 3A. You're probably only going to get through the first 5, maybe? Is that how many? You don't know how to write an equation yet. But I'm going to do this completing the square problem right here. The first 4? Okay, yeah, the first 4. All right, I'm going to leave the squared terms on this side and move everything else to the other side. Guys, please watch, if nothing else, okay? Then I'm going to factor out the 2. We haven't done one with a coefficient before. I should have started with this one. When you factor out the 2, now when you complete the square, look what we really added to that side. Did we really add a 36? We added a 2 times 36, which is a 72 over there. So we end up over here with a -x plus 0. But we don't want the 2 on this side, do we? We want the k 4p to be on the other side. So if we divide both sides by 2, we get a -1/2 x. That was disgusting. All right, we'll work more on completing the square and writing equations.